So today I'll be taking this webinar or on in-vehicle networking and communication protocols in the automotive industry. So just to set the context, this webinar will be giving you a brief, I'll say, introduction to the automotive industry, how it works, all the structures, how it is, what the job opportunities you have, and how you can get into this domain. So let's not waste the time and move quickly. So the table of content for today's webinar will be this. First will be the introduction to automotive industry, where I'll be explaining you what is automotive industry, what and all are included in this, how it started, and also what are the different structures in this. Then I'll be explaining you the in-vehicle networking, how it helps in today's automotive industry, how it helps the cars to work properly, then the communication protocols used in the vehicle these days. Then I'll be taking you through the current trends in the industry, how the industry works today, what are all the technologies which are the part of the industry these days, and the evaluation what is happening in the automotive industry. After that, there will be short discussion, or you can say I'll be introducing you to the career path and the job opportunities in the automobile industry, and heading with the Q&A. Okay, so the first is the introduction to automotive industry. What is automotive industry? So automotive industry, basically here you can see on the slide, I have written a basic, I'll say, introduction about it. It is the business of producing and selling self-powered vehicles, including passenger cars, trucks, farm equipments, and other commercial vehicles. So it's what it does it by allowing consumers to commute long distances for work or for shopping or entertainment. We are using car, right? So this is all the part of your automotive industry. It started by Carl Benz in 1888, the first production, and in France under the same license from Benz, it was started by Emily Rocher. And when I was a fresher, I think so only that automotive industry is basically your mechanical part, right? We when we think about car, what we think, okay, it's mostly about the mechanical things. We not think that okay, there will be electrical or electronics or Java or even C Sharp and Python will be somewhere included in the car, and how it works. So automotive industry is not only limited to the mechanical domain. Let me very clear here. It has expanded its wings to the electrical, electronics, and other technologies too. So it's not only limited to mechanical part. We should not think that okay, if I'm only well versed with the mechanical, or if I would have taken mechanical branch, I can go in the automotive industry. No, if you are from electricals background, you can still go there. If you are from electronics, you have a good job there also. And even if you are good with Java or C Sharp or cloud computing, I'll say data analysis also. These all the are the part of automotive industry too. Now it's not a very small industry; it's a very large industry with a very good jobs and other the leading technologies too. Now coming to the part that what makes the automotive industry, it is mostly or mainly comprises of OEMs, suppliers, tool developers, and the service company. Now come, so basically this is the structure of automotive industry. First is your OEM, then you have system module supplier, you have component suppliers, and then you have part suppliers. What is OEM first? So OEM is basically your original equipment manufacturers. When we say original equipment manufacturers, what comes by the name only, we can just say that okay, someone who is originally developing or making any equipment and holds a complete rights on their product. So that will be the OEM. So if we see in this perspective, you can tell the car companies basically they all are the OEMs. If we'll see in the cars perspective, so if I'll say, let's take the example of an Indian OEM, we say Tata or Mahindra. So they are what? They are the original equipment manufacturers of the cars. They are giving you a complete product. They are selling a product. So they will be the OEMs for that very car. Now we have suppliers. So suppliers are basically defined as companies that manufacture goods that are used in the production process of an automobile or a car, and become part of a automobile, such that they supply these goods directly or indirectly to any automobile manufacturer, or OEM say. So suppliers are again divided into three parts here, where will be tier 1, tier 2, and tier 3, which I have just shown here, that system module suppliers, or component, or the part supplier. And when you say suppliers, they can be normals, very small also, such as the screws, or the entire assembly parts, such as the complete fitted door modules of the car. These are also the part of supply chain here. So you can say this is supplier pyramid here. So here you can see a car is not a normal networking or something, normal structure. Here you can see the distributed networking of the car. Here we have CAN, here we have Ethernet, here we have FlexRay, LIN, and MOS. And you can see the wires right here. It's kind of very complex architecture when it comes to the car. It's not only comprises of the mechanical parts, like we have doors, we have brakes. No, to maintain all these mechanical parts, we have something called ECUs, which I'll be explaining you in the coming slides. And those ECUs are connected through different protocols, which are they are based on different protocols, and they are based on different diagnostic protocols to get the data from the car. So a simple example here I have shown you with this image, that's explain you that how the distributed networking is there in the car, and it's a kind of complex thing. Now comes to the main topic which we are discussing, which I'll be explaining today, that is in vehicle networking. What is in vehicle networking? And now the car is a very complex system, as I shown you the previous slide, with more than 100 of functions operated by the means of small ECUs. And ECUs are called as electronic control units, and associated wiring. So to connect the ECUs, we have the wirings also. And a large number of ECUs are located throughout the car. If I'll say a normal, let's say a luxury cars, let's say example of BMW or Mercedes, we have like 100 to 200 of ECUs connected in that very cars. And suppose we have 100 electronic components in a car, of course we need some kind of protocols to route the messages, or to route the information properly to each of the ECUs. And let's take a not so luxury car, and let's say take a Tata or Mahindra. And here we have a normal to 15 to 20 ECUs, which is not that very complex, but still at the same time it's not so easy also. So ECU, what is ECU? Electronic control unit, which is a very small device, I'll say, in a vehicle's body that was responsible for controlling a specific function. Let's say when you sit inside the car, what you see first? Basically, we see the music system, right? Or we see the speedometer, which we call normally as a instrument cluster, and the infotainment system you see, which where you plays the music, or where you hear the FM, let's say where you watch the videos. So that all the complete system is called as infotainment system. Same way we have same way, so these two are examples I have given, are the ECUs in the car, that is electronic control unit. Same way we have electronic control unit for engine systems. Same way we have electronic control units for our HVAC system, that is your AC. Same way we have for this airbag deployment, we call it as ABS. Or for the locking and unlocking, we have IMMO systems, we call it. And for the rear view of the car, to see what's behind, we have RVC, that is called rear view camera. So similarly, we have so many ECUs inside the car. Now, if I'll connect everything directly, there will be no means, because everything needs information from everything, right? Like if I want to see the speed on the speedometer, of course, I need to know at what speed my car is going, right? So for that, I'll be taking the speed input from somewhere. Let's say my engine is giving me the speed, the input for my cluster, for my speedometer. So in that case, I need input from engine management system, that is EMS systems, to my cluster, that is speedometer. Now for this, I need some kind of networking, right? I cannot directly ask, or in the vehicle, that cannot directly take, the cluster cannot directly take an input from that. So for that only we have in vehicle networking. What it does is it connects the vehicle electronic equipment and facilitates the sharing of information and resources among the distributed applications. So whatever the applications we have, so it takes the input from everywhere, and wherever it is required, the networking is will be used for the same purpose. These control and communication networks are based on serial protocols, replacing the wiring harness with the in-vehicle networking. In the coming slide, I'll show you how the system was before the invention of, or I'll say before the in-vehicle networking was introduced into the car modules, and how the system is now, how efficient it is, and why we need the in-vehicle networking, and also why in-vehicle networking is required. Message transfer and its analysis also happens in the same layer where we do the in-vehicle networking concept of the car. So I've given you one example. Now, you should understand that why in-vehicle networking is required. One more example I'll give you, that suppose see the RVC. You want to deploy RVC, suppose rear view camera. Now, in this case, you put a reverse gear in the car, and suddenly your infotainment screen will change. Infotainment, I'll say the music system, where you see the everything. It changes and it gives you the behind view, right? It gives you what is happening behind the car, and so that you can park your car easily. Now there should be some algorithm or some technique or some way that this information or the information from your camera is getting passed to your infotainment system, right? So this all happens through your in-vehicle networking. We'll go deeply in the same examples what I have told you now in the coming slides, where I'll be explaining you why this in-vehicle networking concept was brought up. So in this slide, you can see a hardwired integration of the ECU. I told you, right? ECU, electronic control units. So suppose we have four control units here: ECU1, ECU2, ECU3, and ECU4. Now you can see every ECU is connected to each of the ECU. What all problems can happen? Suppose I need something on priority. Suppose my vehicle is going to crash. Now an accident is going to happen, and I need a message which says that a speed is cut down from 100 to 0 directly, without in a proper way it has been cut out from 100 or say 80 to 0. It is not a proper way to cut down the speed. It has happened without deploying the brakes, and at the same time someone is playing music on the car. Now which information is more important? Of course, the information which is very much important here will be the speedometer information. Now if there is no priority of the messages, that which message should go first and which should not, what can happen? Suppose ECU1 is transferring the speed message to ECU2, and ECU1 is transferring the same message. Let's say ECU3 is transferring the music message to play a song to ECU4. In that case, what can happen? And if there is no priority of the message, suppose my ECU3 message goes to ECU4 and my music is playing first. In that case, what will happen? My car will get crashed. The accident will occur. So this is not a proper way when it comes to decide the priority of the messages in a hardware integration, or I'll say conventional, very old method of networking. On the other hand, suppose we have in the down, you can see sensors and actuators right here. Every ECU is using sensors and actuators. Every other ECU is using sensors and actuators. Suppose one sensor and actuators can be shared with two ECUs, right? In that case, here I can see for everything we have different. We cannot take the inputs, or if we take the input, it is a long way to go because there are so many wirings here. So there is no shared what I'll say information, or maybe in a better way. Along with that, if I have more connectors and if I have more sensor and actuators, the vehicle wiring harness is going to be more bulky, right? The wiring, we require more number of wires or more amount of wires for the vehicle. In that case, what will happen? My vehicle weight is going to be more. If the vehicle weight is going to be more, I'll not say that is a proper thing to do in the automobile. We need our cars to be very light. Okay, fine. So these hardware integrations was not very conventional. That's why we bought in-vehicle networking in the concept. Now in the next slide, this slide, you can see a multiple bus network concept, which is kind of running these days. This is the concept of today's car. Here also we have ECU 1, 2, 3, 4, 5, 6. I have shown you say 6 ECUs here, and they are connected through CAN bus. I'll be taking you through the CAN also in the coming slides. And ECU 4 acts as a gateway. So what will happen here? Every ECU will transfer their data on these two buses, which is a serial protocol here, CAN bus. And then what will happen? Whoever needs what information, they can take it from the bus. So this is more feasible, right, than what happens in the previous slide. So this is the concept, a multiple bus network concept, which happens in these days. Are normally our all vehicles are running on this kind of concept only, and this concept we will not call as concept, we call it as topology. So this on this topology only, all the cars, I'll say basically all the cars are running, and this will be a responsibility again to design the architecture and the network concept for the car. And these also have the job opportunities. I'll be taking you to that slide also. Here, what is gateway here? I'll say whatever the information from ECU 1, 2, 3, if it has to go through to ECU 5 and 6, it has to go through this ECU only. And if 5 and 6 ECU has to transfer any data to these ECUs, I'll say ECUs as control units, it has to go through a gateway. It's a kind of gateway which allows the message transmission between the both the buses. Let me know if I'm going very fast. Now, the question is why in-vehicle networking is required. I have pretty much cleared in the previous slide and ML discussion. The first is easy to integrate more issues onto the network. Right, we saw how our bus is connected. It's a serial protocol. Even if I need to connect one more issue, suppose my car goes in the production, and now I need to enhance one more issue. I need to add one more issue. Suppose a government guideline came that every car needs to have speedometer. All say suppose every car needs to have a RVC camera. Now, if my car is already launched and I want to include a camera inside the car, as per the government guideline, it will be very much easy to integrate in this multiple bus network concept than to include in the old hardwired integration concept. So it's very much easy to integrate more issues on the network if we are going through in vehicle networking concept. It's just you have to tap two wires of each ECU of the new ECU as a CAN high and CAN low to the bus network, and rest you have to give one what I'll say positive and the ground. That's all is required. Only four connections you can connect it to the wiring harness, and you can just release the vehicle again. Then the next is it will minimize the number of physical connections. So if we'll go by in-vehicle networking system, as I told you, the wiring harness will be less, the connectors, the actuators, the sensors, because they can be reused again and again. The information can be routed it through one ECU to another ECU. It would be very easy for us to minimize the number of physical connections. If you want to see wiring harness, right, you can go to Google and you can just type the wiring harness, and you can see the how the car wiring harness runs. It will be complete a circular motion. Sorry, as a motion, it will kind of circle. A wiring harness will be distributed alongside the car, and then you will be have one input as a OBD, which will be if you have set if you have noticed, if you'll sit inside the car, OBD will be down your seat most probably, or otherwise it will be down the steering. There will be a socket kind of thing like a chargers only, and there will be pins inside that. 16 pins will be there, and where you can connect your tool and you can get the input out of the car. So basically complete wiring harness, whatever you have seen, it will be one output as the OBD, and the car data can be taken out from that. Third is more reliable, as we saw, as I explained you, and the difference between the old and the new vehicle networking, it is more reliable to use as of now. It is easy to use, and the cost reduction also because of the above 2 points. Of course, even if I'll decrease 10 rupees cost, right, there will be huge impact on the market side, because if we'll produce lakhs of car, of course the 10 rupees also takes matters for us, right? So it's very easy to use, and for the cost reduction purpose also, if you use less number of parts, then of course cost reduction also will happen. And I told you already that reduction in number of redundant sensors and connectors also will happen if we'll go through the networking concept of in vehicle. Coming to the communication protocols, now what happens? So now we have a networking, we have ECUs, and we have some messages which messages, when I say how we send the text messages to each one, right? We send some information to someone, right? Same way our one control units wants to send one information to the other one, right? So it also has to have some protocol levels, right, to send the messages in a proper format, in a proper way, so that the other person can understand that very message, and they can take out the information from that very message and use it for their work, right? So same way, we have, so for this only there are different communication protocols across the automotive industry which is getting used in different levels. And when I say it's a kind of, there is a kind of difference when you go to the luxury cars and when you goes to the normal cars. Normal cars will not use that very costly protocols. I'll say ethernet will not be used in a normal cars what we see as a Tata or Mahindra, because using an ethernet will be very much costly for Mahindra products. So in that way what will happen, we use lin and can, because there is not that much speed is required, because we do not have 200 of ECUs. In normal cars we have only 20 ECUs, so we need not to get that much of speed. So why not we only go through lin and can? I'll explain you one by one what is lin and can. I have taken two examples here today for today's session, which is only lin and can, and rest of the things we can see later, or you can go through them by yourself also. So I told you why communication protocols are required, right? Because to understand, there should be a proper structure of the messages which one ECU wants to send to other, or suppose if information is shared on the CAN bus, it has to be in a proper way so that everyone can understand. So that's why we bought different protocols to the vehicle networking concept.